Thank you. Thank you. Well, hello, everyone. So as they just said, my name is Dominic, and I lead the team working on Polaris at Shopify in Ottawa, Canada. So for those of you who aren't familiar with Shopify, we're a Canadian company working to make commerce better for everyone. So today, over 600,000 merchants use our platform to handle every aspect of their business, from managing products and orders to selling online or in person using our point of sale. We've also seen a lot of growth in the last while, and we're now well over 3,000 employees, which is a part of why the design system is so important to us. So today I'm going to be talking about these three things. What is a design system, and what does it mean to us at Shopify? How we build a design system and the technologies we use, and how we continue to evolve and scale as the company grows and the teams grow. So first, before we get into it, what even is a design system anyways? And I think this is an interesting question because design systems can mean different things to a lot of different people or different companies. To us at Shopify, though, it's really the way we work together when building the interface for our product. It's everything we have learned about building a great experience. It's our language we use to communicate with each other. It's our documentation and guidelines. And it's the tools and components. The system sets the baseline for quality across the product. It enables collaboration, and it brings the different UX and engineering disciplines closer together. So Polaris gives anyone using it, or anyone building a merchant experience for Shopify, the help of our UX team and all that we have learned already. It allows people to focus on the hard problems that they're trying to solve, and instead of trying to solve the same things over and over again, like what color a button should be, or what heading level this should use. And Polaris is not only used by the teams within Shopify, it's also used by third-party developers who are building apps for the Shopify ecosystem. And we think this is really important because it brings coherence to the product, and the merchants can use a more familiar interface when going from our core admin to the apps on our platform as well. So as a product grows more complex and teams grow in size, this coherence and efficiency becomes even more crucial. I think that as you scale, you need to embrace this kind of systematic thinking. So in a way, I think this is kind of similar to how a system of roads works. Roads are built to get people from one place to another. The path is common enough that we decide to spend the effort turning the land into something that can be more easily traveled. And it may be more work up front, but it helps many people save more time every day that it's worth it. And this is the same thinking we use when building a design system. Only instead of helping getting people from place to place, we want them to be able to complete tasks in our interface. We look at the problems that are common and try to abstract the solution into something that others can use the next time, so they don't need to solve that same problem over again. So also, roads are designed to work cohesively together, which allows people to continue moving at a really fast pace, even though there are many others around them that they need to coordinate with. So this may be less necessary if you're in a rural area or a small town, but as the number of people increase, like in a city, this becomes more and more crucial to help things keep working efficiently. So we have highways and road signs, traffic lights, and all sorts of things that can bring order into what could be chaos. And this is why we need a system as things grow in size and complexity to keep these things moving efficiently. So roads not only need to be designed to work with each other, but they also have to be designed to be harmonious with their environment. And a design system needs to fit with both the environment and also evolve with it too. It has to be complementary to the product and the people building that product to work. So if the system itself is like a road, then I think the documentation for the system is the map. And having the roads built is all well and good, but you need the map to tell you which road to take to get where you want to go. And this is why documentation is so important to us, and we try to document as much as possible in Polaris. We document things like our content guidelines, so that anyone writing copy for Shopify can learn about the voice and tone we use, or our preferred vocabulary, and how to use simple language to reach a larger audience. It even has the nitty-gritty details like the grammar and mechanics we use, when to use an M or an N dash, or whether you should use an Oxford comma, which you should. This is important to us, though, because consistent interface content is core to a well-designed user experience. We also document our design guidelines. So this includes the colors we use and their intended meaning and when and where they make sense, or our typography and type scale and how to apply it to your design to get clarity and hierarchy, or our spacing system, the icons we use, our illustration style, sounds, and so much more. And all of these things together help us align how we are approaching design and make sure the work that we are shipping is cohesive. We also document our components. To us, a UI component is a solution to a reoccurring design problem. So let's say you need to take input from a user or need to display a message to them. We have a component that can do that for you. And the great thing about making these reusable components is that they can get better over time the more people use them. Components help us build faster as a team, but also make the work more consistent and improve the overall quality of the output. So one of the ways we increase quality is by baking things like accessibility right into the system. So accessibility is crucial to our mission at Shopify. We want to make commerce better for everyone, and that includes people that might be living with some sort of impairment. So we build with semantic markup, and we test our components with various assistive technologies like screen readers or screen magnifiers. And this won't do everything for you, but it sets a really good baseline for creating an accessible experience if you use our components. So along with the guidelines and components in our style guide, we also distribute a UI kit for Sketch. And this is where you can find a visual reference for the components and patterns that we have in the system. And we chose to distribute this as a Sketch file because Sketch was the design program that most of our designers were using already. And we also combine this with a Sketch plugin called Polaris Telescope. That allows people to open the documentation for a component right in Sketch. And I think it's really important that you're meeting your users where they are most comfortable and integrating with their workflows that they already have. It will reduce friction and get more people using the system more efficiently. So now you know a bit about how we were thinking about a design system and why we have Polaris, but how did we build it? So as you can probably guess from the title of the talk, we used React at Shopify, and we also used it to build Polaris. We use it for both building the component library, but also our documentation and style guide. And we chose React because it mapped really well to our component model and how we were already thinking about building interfaces. It really focuses on the components and their APIs and allows us to more quickly build with them. So we also use TypeScript. And you've already heard a bit about TypeScript today, but it allows you to have more strict type checking so that you can catch bugs and errors before they go to your end users. People using the component library can also benefit from this if they are using TypeScript too, because they can get type checking on the props for the components they're using. And TypeScript also gives really helpful, or is really helpful in an editor like VS Code because it can give you feedback and auto-completion right as you're writing your code too. So as you can probably tell, we have a lot of content in our style guide. There are a lot of words. And we always knew we wanted to focus on content when building Polaris because it was so core to our experience. So we chose to use Markdown. And Markdown, we found, is a really approachable way for people, especially non-developers, to be able to write and contribute to the guidelines without having to learn HTML or another templating language. In fact, I would say most of the documentation in our style guide was written by designers and content strategists. And I think this is so important because it gives ownership over the system to everyone, not just the developers on the team. So we also use what are dubbed as design tokens as part of our foundation. Design tokens are named entities that map to a design attribute. The concept originated from the team at Salesforce, along with their open source tool for formatting and transforming them called Theo. So we use design tokens to store our colors and spacing information so that we can share it across the different implementations we have of our components. So it allows us to update one value, like let's say we want to change a color, in one place, and it will trickle down to all of our component implementations, whether it be the React components, CSS, or our mobile components in iOS or Android. So let's take a look at an example of one of our components. This is a banner. It's used to show a merchant an important change to their shop or message. And this is how you would use it in code. Up top, you'll see the JSX used to render the component, and below you'll see the output. So you'll notice we passed two props to the banner, a title and a status, as well as a child paragraph. Having the title as a prop allows us to make sure it is a string and that it gets rendered with the correct heading level and style. The status prop maps to the color and icon that we use in the banner, which conveys a status to the merchant. So for example, in this case, it's success, and it's green with a check mark, but if it was critical, it would be red with an error icon. And this may seem like a more restrictive API than, let's say, accepting a color for the status or a JSX node for the title, but this is actually by design. We always try to base components and their variations on their purpose, not their visual style. And the reason being, it allows you to evolve and improve on these components going forward because we're more confident we know how they're being used. So for example, let's say we wanted to change the success icon or decided that that color wasn't quite right for the message we were trying to convey. We could update it, and it would get updated for all of our consumers because we're confident we know how it's being used. Whereas, let's say if we did take a color, we wouldn't know why they chose that color, so we wouldn't be able to update it confidently. So this is what the TypeScript interface looks like for the props a banner component accepts. There are a few props here, like the title and status prop I mentioned already. But if we look at the status in the interface, we'll see it points to a type of status that's defined elsewhere. And this is where we define status in what's called a union type. That means that the status prop can be any one of these strings: success, info, warning, or critical. So looking at the action or secondary action props, we will also see they are defined elsewhere. So our action types are shared across many different components. And it means we can have a consistent interface, whether you're adding a button to a page header or modal or an action to a list. You can use the same shape of object everywhere. And this is what that action interface looks like. These are all the things that are common between all of the action types we have. Every action can either behave like a link and pass a URL, or like a button and pass an on-action callback. And these two interfaces extend from that base action interface. That means they include everything that was in it, but then add something on top of it as well. So the first one adds a prop to mark the action as disabled, and the second one sets the action as loading so it can show a spinner. So looking back at our original interface, you'll see the action prop we have both disableable action and loadable action that I just showed you, joined by an ampersand. And this is what's called an intersection type. It means that the prop will accept the properties from either of those interfaces. So you could pass loading or disabled to it. So this is really powerful. It allows us to define the shape of all these props, no matter how complex they are. It allows us to share these more generic types across components as well. Also, you notice we add a comment above each of the props here. And we actually use this to automatically generate the documentation in the style guide. So this is how we power what we call our playground. And this not only documents the API of the component, but it also gives you a way to immediately try it out and see the results. So it turns strings and union types into text fields and select boxes, which actually let you play with the props and see the result. So this will update both the code in the editor, but also the rendered preview above. And you can edit the code manually yourself in the code editor as well. And it's a really quick and easy way to prototype something or just play around and learn. And we found this good for other disciplines, especially non-developers, to become more comfortable with React and JSX because they don't need to know how to code to get started playing with a component. So having the API docs auto-generated is all well and good, but that wasn't all we wanted to document about a component. So we decided to have a Readme file in each component directory that would be the source for all the guidelines about that component. Every Readme starts with the problem the component is solving. It will include best practices, some example do's and don'ts, and content and accessibility guidelines. We also write the examples right in the Readme files as well, including the code snippets. So these examples are what get parsed and used in that playground I just showed you. And the nice thing about writing all of this in the Readme file is that you don't even need to necessarily open the style guide to learn about using a component. You can open these Readme files right in your code editor or even browse through GitHub. It also keeps the documentation close to the source code, which is easier to keep them in sync and also have them reviewed in the same place when you're adding a new component or making changes to a component. So we found this works really well. So we have a component. It has a pretty solid API. It's pretty well documented now. But now we need to style it. And as Kasia already told you earlier, there are many different ways to style a component in React these days. But for us at Shopify, we decided to continue using Sass, but use CSS modules as well. So we use Sass for a few reasons. One of it that most of the company was already familiar with it. But it also helps us share values, including those in our design tokens, through a series of functions. So in this example, you will see we use one to get an animation duration. And then we also use it to grab some colors from our color palette. so like color white and color teal. And all of these colors map back to that color documentation I mentioned earlier. And this makes sure we're using the same language when we talk about and use colors. It also makes it easier when it comes time to implementation because there's no question about what hex code we should be using or what value we should be using for a color because it all maps back to this. So going back to the example of the spinner component, the class names we use here are pretty generic. And that's because we're using CSS modules, which allows us to write these simple, easy-to-understand class names, but they'll be scoped locally to the file. And that means you don't have to worry about naming or about collisions. You don't have to worry about using a naming convention like BEM. And part of our component philosophy has always been that components should be isolated. And they shouldn't have other components or code causing side effects in them. And this also applies to the styling. We also always warn consumers against targeting these class names to override the things they wanted to do. And CSS modules actually takes this one step further because the class names are obfuscated in production. So even if they wanted to override those classes, they couldn't. So CSS modules are great. They made it easier for us to write our styles, but it also introduced an interesting problem. We wanted to distribute Polaris as both that React component library, but also a set of static CSS files in HTML that consumers who maybe couldn't use React in their app could use. And using CSS modules meant that all these classes would be scoped, and we couldn't necessarily rely on them, or they weren't predictable. So we came up with a method for generating almost BEM-like class names using our naming convention. All components and subcomponents use upper camel case, and the root component class must match the component and file name. So in this case, that's spinner. The variations of a component use lower camel case, like size small or color white. And this allows us to, when we build, create some tokens and take this sass and turn it into this CSS. So we end up with a nice namespaced and understandable class name that we can rely on. It means we can still write our code using simple names, and we get the benefits of CSS modules, but we can still generate these static files that consumers can use without maintaining two separate code bases. So that's how we get the static styles, but we also needed the HTML to go along with that. And we also didn't want to have to maintain two separate code bases for the HTML examples. So we actually just used a little trick to get the HTML to render in the style guide. We were already rendering the React components in that little demo that I showed you. So we just copied the HTML out of that rendered component and output it into the code editor. So this meant that the React components were still always the source of truth for what the markup was going to be, but consumers didn't need to know that. They could just copy and paste this into their project and start using the HTML themselves. So when building our React library, we knew we wanted to be as agnostic of technologies or libraries as possible. Obviously, it was going to depend on React, but we didn't want to make assumptions about things like how users were going to be fetching data from the server or how they were going to be storing state. So this meant we couldn't rely on something like Redux to pass more global information down to our components. So we decided to use React's built-in context API to do this instead. So this allows us to have a top-level app provider component that can take things like translation strings for internationalization or app configuration for an embedded app. And it will share that with all of the components that are used in an application, all of those Polaris components. So here's an example of us using our app provider component to pass a custom link component. So a lot of people using Polaris want to use a router like React Router. And that includes its own link component. So we wanted to make this configurable. So here, we create a new custom link component, pass the props down to React Router's link component, and then pass that custom component we just created into the app provider. The app provider could then use React's context API to share that custom component with all of the Polaris components in the app. So this means that instead of where we would render a normal A tag, it will instead use the custom link component and in turn React Router's component. OK, cool. So that's a bit about how we built Polaris, but it doesn't end there. A design system is never finished, and it has to keep evolving with the team, the product, and the end users to continue being useful. This means watching for any newly emerging patterns or recurring problems and finding ways to solve those in a systematic way. People often ask if having a design system means there's no room left for creativity or pushing boundaries. And I think it can, but the system is there to set the baseline for quality in the product, not the top end of the quality. We want all the teams using it to push those boundaries, to try new things, and when the system isn't working, let us all learn from it. But how do you learn these things? As more and more people are using the system, and more teams are being formed or new features are happening, it can be harder and harder to see these, especially as the company grows. But we've come up with a few different ways to help us get visibility into these things. One of the ways we do this is by holding office hours every week. We encourage people from other teams to drop by and show off the work they're working on, or even just get help with a problem they're facing. And this helps us understand where the pain points are with the system, but also gives us a chance to give feedback on their work and hopefully get better quality out of all of it. So we use GitHub to manage all of our issues and contributions. And we ask people when they're using Polaris to open issues as they find bugs or if they would like to see a new feature. And then we ask people to vote on feature requests like this one with a thumbs up emoji if they think it would be valuable to them too. And this at least gives us some indicator about what people are hoping for and helps us prioritize what things we might add to the system next. So when teams are pushing those boundaries and hitting limitations, a new feature may have requirements that the system doesn't cover yet. So rather than immediately adding every new feature that's proposed, we instead like to see those patterns proven in the product first. And this is why we usually ask teams to create a fork of their component in their own project and try it out there first. This lets us see it used in the real world and get a better understanding for what the problem is. It also gives us some time to think about the API and abstract it. And it helps us be more confident about the things we're adding to the system. So if we are happy with it, we'll then commit it back upstream, and everyone will get those improvements. So evolution can also happen in a smaller, more invisible way. And that's just through the regular maintenance. As time goes on, problems will build up with the system, much like potholes would in a road. And in the context of a design system, these are things like bugs or out-of-date documentation or maybe unclear examples. And I think it's really crucial that you spend the time to get these things fixed and make sure the system stays healthy, to keep people's trust in it, or they won't use it. And we try to give the teams using Polaris the ownership to be able to fix these things themselves when they run into them. We encourage contributions and offer support to anyone who is willing to help. We also occasionally organize what we call a bug bash, which is a day where we get together as a group and try to knock out as many of these small issues as we can. And we encourage people from outside the team to join as well. And I think this has helped us not only improve the system, but also the relationships with these other teams and people using Polaris, and hopefully set them up for more contributions in the future too. So a road is only going to be needed if people are continuing to drive places on it. If no one used or maintained a road, it would eventually erode away. And I think this is the same with the components and patterns in a design system. If no one is facing the problem it solves anymore, there'll be no need for it, and it may as well go away too. And this is why it is so important to make sure you are building the right roads. You have to stay close to the people who need the roads so you can understand where they want to go. And you need to build those. For us, that means both understanding the teams using Polaris to build, but also the merchants who are our end users. Building the most comprehensive design system with an amazing developer experience means nothing if it doesn't actually solve the needs of your end users. And I think it can be easy to get disconnected from the end user while you're working on a design system because a lot of the work we ship day to day might not directly affect them. And more often, we're hearing and supporting the teams using the system and hearing their problems about it. So I think it's really important to find ways to stay close to that front line. After all, the whole reason we have a system is to be building better experiences and, in turn, a better product. We have to make sure that we're always keeping these people in mind and that they are the driving force for all the work we do. Awesome. That's all I have for today. Thank you. I will say, though, our style guide is open to the public, so polaris.shopify.com, and also Polaris React is open source. So if any of this interested you, I would suggest digging into that. I'll also be hanging around at the break, and we'd be happy to chat more about it or answer any questions. Thank you.
Sweet. Thank you.